Let us see the problem number 1 from HOTS. In quadrilateral ABCD, here is the quadrilateral ABCD. AD and BC are parallel. AD and BC are parallel. Diagonals AC and BD meet in point Q. Diagonals AC and BD meet in point Q. AQ is 1 upon 3 times AC. AQ is 1 upon 3 times of AC. Then prove that DQ is half BQ. Now let us understand the thought process for the same problem. To prove that DQ equal to half BQ is as good as to prove that if I transfer this BQ here, I get DQ upon BQ equal to 1 by 2. So remember once again, to prove this is as good as to prove this. What did I do? I transferred this BQ on the other side. So we'll go to the denominator and we will have to prove now DQ upon BQ equal to 1 upon 2. We come across the ratios in similarity. So the problem is based on similarity. Now, I'm talking from your last paper's point of view, where there will be a mixed bag questions, so that you will understand the problem had something to do with the chapter similarity. Now, if I have to consider the theory of similarity, what I'm going to do is, I'll consider AD is parallel to BC, AD is parallel to BC, AQ is 1/3 of AC. So AC does include AQ, so it is AQ and QC which makes the the complete side AC. In the final answer, I need DQ as well as BQ. So if I want DQ, BQ, AQ, QC, AD and BC, once again repeating, I want DQ, BQ in the final answer. I have AD parallel to BC. I have segment AC which includes AQ and QC, clearly indicates that if I prove this triangle AQD and BQC similar, my problem will be solved. So I am going to consider the triangles ADQ and CBQ. For these two triangles, these two angles are congruent because they are alternate angles. As the lines are parallel, alternate angles are congruent. Similarly, these two are once again alternate angles. As the lines are parallel, alternate angles should be congruent. So the triangles are similar by AA test, writing their corresponding sides. Now in the final answer, AD and BC, if I consider AD and BC, are they present in the final answer? No. Is DQ and BQ present? Yes. What about AQ and CQ? They are the two parts of AC. So we will choose the first and the second ratio. Here it is. This is what I want in the final answer, and this together makes the side AC. Now we will use this. AQ is 1/3 of AC. If I transfer 3, I get 3AQ equal to AC. Can I write AC as AQ plus QC? Yes. So let's write down AC as AQ plus QC. Transferring AQ, I get 2AQ equal to QC. Rewriting the step number which we have written in 4 as it is, and now replacing 2AQ equal to AC, that is this segment I am going to replace as 2AQ. This will get cancelled. So I will be left with 1 upon 2 is equal to QD upon QB. Transfer this QB, I get the answer half QB is equal to QD. Half QB, that is BQ, is equal to QD, that is DQ. So a bit difficult question, but if you have understood the thought process, I don't think the problem is difficult.